It's the age-old question, or maybe it's not. Relational versus non-relational databases. Holy moly, I'm fired up. Let's have a look. What's the difference? What does this mean? Why should we care? Well, there's a lot that's going on in databases, and the difference between relational and non-relational is absolutely key when you're trying to decide what the heck do we want to build? What database do we want to use? You first need to understand, do I need a relational database or do I need a non-relational database? So let's understand it. Relational databases use SQL and are very structured. This means that they're actually tracking all of the different relations between data. So if you have a highly intertwined relationship type data structure, then databases that are relational are great. But it also means that they're very strict, they're very rigid, and they don't have a lot of flexibility. This is different to a non-relational database, which is sometimes called a NoSQL, because we use SQL in the relational one, a NoSQL database. And it offers a lot more flexible, loosey-goosey type of schemas so that your data is kind of in there, but it doesn't have the same structure and relationships that it does in a relational database. So a high-level overview of this is where our non-relational databases can use a variety of languages and they have a very flexible schema, whereas our relational databases are using SQL and they have rigid schemas and it may limit their performance. So already you should have a bit of an idea, what data is best for me if you've got a data in mind that you want to put in a database. But we can go into a bit more detail into the NoSQL, or these are the non-relational databases. The interesting thing is that if there's no relationships, how does it actually organize itself? And that's where these key value pairs actually come into use. These are how non-relational databases or NoSQL databases actually organize all their data. Using key value pairs, every piece of data has a key and a value. And the key is the item and the value is the attributes. And this allows a lot of flexibility when you are adding and removing data from a NoSQL database. For example, you might have a key value pair, which is item name and then quantity. So item name is the key and then quantity is the value or the attributes. So a key value pair would then be the item name. Say the item is called biscuits. So now biscuits is your key, and then quantity, which is your value and your attributes, quantity would be 5. So now you've got biscuits, 5. And that's telling us that there are 5 recorded biscuits in your database. So if you wanted to add or remove biscuits from your database, you would just look for the key, which is biscuits, and then you would update the value, which is the attributes. So you might say, I want to add in 2 more biscuits into my database. Then you just look for the key biscuits and update it, tick, tick, up to 5, 6, 7. Or if you wanted to remove them, then you'd look for the key biscuits and then remove them 5, 4, 3. So that's how a NoSQL database can work using that key pair structure. Now, an example of a NoSQL AWS is actually DynamoDB. DynamoDB is a serverless database, which means that you don't need to worry about any underlying services powering it. You also don't need to maintain or install those servers yourself. Whether you have 2 items in your database or 2 million, DynamoDB will handle the scaling of that for you. And it will also send identical copies of your data to different availability zones. So you don't need to worry about the sometimes pretty complex task of managing data availability yourself. DynamoDB also has millisecond response time, which means it's great for high performance and high availability. And a great example of this is an event that Amazon ran called Amazon's Prime Day, where there were 7.11 trillion calls to the DynamoDB, peaking at 45.4 million requests per second, which is just crazy to even think about. So with DynamoDB, you can add and remove items at any time. There's encryption, both at rest and in transit when you're sending data. And queries in a DynamoDB are not SQL queries. Remember, it's non-relational, so no SQL. They're actually a bit simpler than SQL queries because they focus on a collection of items. A lot of people actually find that DynamoDB queries are easier than SQL queries. In summary, it's very fast, it has a really good response time, and it doesn't use SQL. If we wanted to do a bit of a comparison and look at a relational database versus DynamoDB. So we're looking at Amazon Relational Database Service and in DynamoDB, then you can kind of see here that we've got a couple of different things going on. I mean, with our relational database, it's more for complex data, it's for relational joins, and it's for high availability. Whereas our DynamoDB is more about simplicity and speed, and it's about non-relational joins. So I hope that was a useful overview. Happy learning. We'll see you in the next video.